Hello everyone, welcome back to my channel. Today we will be doing very famous interview problem, container with most water. So in this LeetCode question, what we are given is, we are given a integer array and the array name is height. It has length n. Each element in array represents a vertical line. So there are n vertical lines drawn such that two endpoints of this array form a container. Okay, so look at this figure here. So what's there is, there are n vertical lines. So if value at a index is 1, then the vertical line height is 1. Value at an index is 8, then the vertical line height is 8, such that these are n vertical lines. Now what we have to do is, we have to form a container from these two vertical lines. Basically we have to choose two vertical lines from this array, and we already have a base as our x-axis. So we are given an array of length n, and each element of this array represents a vertical line on this x-axis, and we have to form a container using two of these lines and give the answer as the container which will hold the most water. Okay, so suppose if we choose these two lines, in that case, what is the amount of water these two lines can store? Okay, so the height of this particular container is 1 and the height of this container is 8, and the area it can hold is this much. Okay, because more than this the water will spill here, so it can only store the water till the smaller height vertical line, right? So if area, so we are considering as a 2D surface, so area is equals to height into width, right? And the height that will be used in this calculation will be the smaller height. So area is equals to 1 into width. What is width? So it is the index. So this is 0th index, this is first index. So width will be 1 minus 0. So it will be 1 minus 0. So it is equals to 1. So choosing these two lines can hold 1 unit of water, right? Suppose we are choosing these two lines. In that case, what will be the amount of water? So the height is 6 and 5. Which is minimum? 5 is minimum from these two. So the area will be 5, which is the minimum height, multiplied by width. What is the width? This is 0, 1, 2, 3, 4. This is 4th index and this is 2nd index. So it will be 4 minus 2. So what will this be? 5 into 2 is equals to 10. So this choosing these two will hold 10 units of water. Similarly, we have to try all the combinations and find choosing which two lines holds the most water. Okay, so thinking about this problem, what's the brute force that comes to our mind? The brute force is that we have to try all the combination of these given vertical lines and give the maximum. So first we should be able to code the brute force. So looking at the brute force solution, we will try all the combination of picking the two elements from this, and we will find the area. So we will keep track of maximum. So what we will do for this is, we will take an element for storing max element, or we can say max water container. So let's name it as max water. Currently it's 0. Okay, and we will loop through our array where n is the size of this particular array. For j, we will do an I plus 1. So j is equals to I plus 1. And j is also less than n. And j plus plus. Now what we will do is, first we need the height that we will use in our area calculation. So that height will be minimum of the given input ith element or jth element. Now we will find the water content, which basically the area. So the area is equals to width into height. So we have height and width is equals to j minus I. So we have this area. Now we need to store the maximum. So max water will be maximum of what, the previous maximum or the newly calculated area. So this will be max water or the area. So whatever the maximum will be stored in this. Now this is the brute force solution. We can see that we are running two loops here. So this will be order of n square complexity and no extra space. But this is not an optimized solution. So look, we have tried different patterns of the two pointer pattern. So we can clearly see that yes, here we have to choose two particular indices from this array and we have to find our best index to give the most water. So this is a suitable problem for two pointer approach. So let's look at the optimal solution of this question. So for two pointer, the intuition here is that okay, we will use two pointer in our input array and we will keep moving, but we need to decide how we have to move our pointers. So earlier what we used to do, we used to have our use case and we used to move our left or right pointer depending on what we need. Now here in this particular question, we know that the area which holds the water is dependent on the smaller pointer. Okay, so if we have 1 and 7, the area depends on the smaller element. So in this case, area will be basically the smaller of these two, 1 into the width of these two indices. So now if we have tried this combination and we have some answer, okay, now to get next answer, which pointer I need to move? Should I move the left one or the right one? That we need to decide. So if we decide to move the right one, moving the right one will not help, because even if we move this, in that case area will be still 1 into width of this and this, basically these two. In that case also, this is the deciding factor in our area. So which pointer we should be moving is the one which is smaller. So we will move left. So every time before moving the pointer, we need to decide if the index at left is smaller than the index at right, then we will be moving our left pointer. Else, if this is not the case, we will move our right pointer. Right will move inwards. So let's try coding this. So we will have a left pointer pointing at 0th index. So this is the left pointer, and a right pointer pointing to end of our array. So height dot size minus 1. Now what we will do is, we will keep a variable for our answer. The variable name is max water, and max water will be initially 0. Now we will run a loop, a while loop, while left is less than right. And now we will pick a height basically from these two. The one which is minimum is the controlling height. So what we will do is, height h is equals to minimum of height left and height right. Now we have height, and for area we need width into height. So we have height, the width is the distance between the two indices. So it will be r minus L. So width is equals to r minus L. So basically right minus left. We have width, we have height. Now we will calculate the area. Now we have the area. Now we need to keep our maximum area till now in this particular variable. So what we will be doing is max water is equals to max of max water till now, or whatever this area was, whichever is maximum will be stored in this max water variable. Now we need to decide which pointer needs to move. So if the left pointed element is the smaller one, and left will be moved forward, and if the right pointed element is the smaller one, right will be moved backward. So what we will compare is, if left is smaller than the right pointed element, in that case we will do left plus plus, else we will do right plus plus. And after this loop, what we will have is, we will have our answer in max water. So we will return max water. So the discussed solution, which was with 2 pointer, the time complexity of this solution is order n, because we are running one while loop, and the space complexity is constant because we are not using any extra space. So the points here to remember is that when we have to move our left or right pointer. So basically when we are comparing the two pointed elements, the one with which is lesser, basically in this case the 1 is lesser than 7, in that case we will move this pointer. In this case 7 is less than 8, so we will move this pointer. In this case 3 is less, we will move this pointer. When both are there, we will move right pointer. Both are there equal, and so we will move right pointer. So in this case what we will do is, we will move a smaller pointer, and in this case what we will move is smaller pointer, now also smaller pointer, and we are done here. So the only thing that we have to remember is that how we should decide which pointer will be moving. If we have understood the brute force, then only this is the addition in this particular approach question. Let's code this solution on our LeetCode. So basically we have 2 pointers, left is equals to 0 and right is equals to height dot size minus 1. So we have our 2 pointers here. Now we will have a while loop while left is less than right. Now what we have to do is, we need a height that will be used in area calculation. So let's take it as h. Int h is equals to minimum of the 2. The 2 is the left pointed element and the right pointed element. So we have the height. Now we need the width. Width is equals to right minus left. Now we need is we also need a maximum water element. Initially the maximum water element is 0. Now what we will do is, we will check our maximum. So this is equals to max of the current max and the newly calculated area. That will be h multiplied by w, which is height into width. Now we need to decide how we have to move our left and right pointer. So basically, if we have this area height, basically height, and we will check our, if this is less than the right pointed element, in that case we will do a left plus plus. Otherwise what we will do is right minus minus. So this is the code. Let's run it. So the test case are passing. Let's submit it. So yeah, that was this about this particular question. So let's meet in with another question the next day. And for more such videos, subscribe my channel and stay tuned. Thank you.